third method for solving linear systems is linear combination. We've solved them by graphing and we've solved them with substitution. And now we're going to solve them using linear combinations. Now these are our steps for solving them, and it does seem like a lot of steps, but once I show you an example, you'll see how this works. Step 1 says arrange the equations with like terms in columns. Basically, line up your variables. Step 2 says multiply one or both of the equations by a number to obtain coefficients that are opposites. And I'll show you what that means in a second. Step 3 says you're going to add the equations. Remember, we're talking about combinations here. When we combine things, we add them. The trick, and this is the whole key right here in step 3, combining like terms will eliminate one variable. And that's how we make linear combinations work. And then, of course, solve for the remaining variable. Once you have solved for one of the variables, just like substitution, you substitute that value in to find the value of the other variable, and then you check. So let's see how this works. Again, here we have a linear system. We're looking for an x and a y value that make both of these equations true. Now, if you're looking at both of these, it says arrange the equation with like term in columns. Our variables are lined up here. Here's our x's, here's our y's, and then here's our constants. Multiply one or both of the equations by a number to attain coefficients that are opposites. Well, we're in luck. We don't have to do any multiplying here because these are already opposites. So all you need to do then is add. Since everything's lined up, just add straight up and down. So if you go -8 plus a -16, that's a -24. 2y's plus 6y's is 8y's. And then -x and +x cancel out. That's the goal of linear combinations. Combining like terms will eliminate one variable. And then we can see here that y equals a -3 by dividing both sides by 8. Not forgetting that's negative. Once we know what one variable is, you have to plug it back in to one of the equations, and it doesn't matter which one you choose. In this case, I'm going to choose the second equation here just because I don't want to deal with a -x, and it honestly really doesn't matter which one you choose. So I'm going to say x plus 6 times whatever our y value is. Well, our y value here is a -3, so I'm going to go 6 times a -3 equals -16. And then I'm just going to solve for x. X plus a -18 equals a -16. I'm going to add 18 to both sides. And we're going to see that x equals 2. So our solution to this linear system, our x value is 2, our y value is a -3. And again, you should quickly double check by plugging it in here, being careful of your negatives. -2 plus 2 times a -3. We want to know, does that equal a -8? -2 plus a -6 does equal a -8, so we're good. And then check it in the second one. Instead of saying x right here, we're going to plug in a 2. Plus 6 times our y value of -3. We want to know, does that equal -16? 2 plus a -18 does equal a -16. So this works. Okay, and checks just have to be really quick, guys. You don't have to spend a lot of time on them, but they are important just to make sure you didn't make a mistake somewhere. Okay, so linear combinations. In this example, you combined. You're just going to add both equations up as long as we have some variables or opposites. We were lucky in this case, they already set up that way. In other examples though, I will show you how you might have to multiply an equation by something.